Hello and welcome everybody to the first knowledge transfer session from the artistic residency Garden of Entanglement within the S+T+ARTS AIR project. My name is Pietschmann and I will be guiding you through this session. In the beginning, I will give you a short overview over the S+TARTS program in general, the AIR project specifically, and the Garden of Entanglement residency as part of that. So you have all the important context you need to understand what we're even talking about. After that, we will hear from multiple people involved in the residency. First up will be Hien Hoang as our artist in residence and her teammate, Daniel Pietschmann, talking about their artistic vision and process going into the project. Then we'll hear from Andrea Giacetti, a scientist from the University of Florence, who will bring the scientific perspective on the residency, as well as Susana Maleros, a scientist from the High Performance Computing Center in Stuttgart, HLRS, who's also working on the project from the visualization side of things. Then the artists will come back to shortly explain their vision for the final installation. And then in the end, we will moderate a 20-minute panel discussion with everybody involved, including other important contributors, namely Uwe Bössner from HLRS and Mauricio Valdes from PINA. So, S+TARTS, which stands for Science, Technology and Arts, is a program by the European Commission and has been around for many years by now. What they noticed is that science, technology and arts, if combined and utilized well, form a huge potential for innovation and societal change, addressing challenges of the economic, ecological, social kind, you name it. So collaborations among these fields open up new valuable perspectives for research as well as business through a holistic and human-centered approach. Different projects were funded under this S+TARTS umbrella over the years, and one of them is AIR. So AIR stands for Artistic Innovation for European Resilience. Our broader thematic focus is the air we breathe and use to perceive the world and communicate with others. All of that under the motto, making the invisible visible. To achieve that and the S+TARTS objectives in general, we are giving artists access to supercomputing as well as other advanced technological resources. And we are funding 10 residencies with 10 artists in 2 specific directions of research. One of them is human AI ecosystems. And the other one, the one we're talking about today, is resilient urban interspecies ecosystems. So this is the time to shortly mention all of the partners involved in the project. We have 8 partners from 5 different countries all over Europe. We have 2 of the biggest European supercomputing centers, HLRS and the Barcelona Supercomputing Center. Also on board is Sony Computer Science Lab from Rome, which is a pure research facility focusing on sustainable cities, augmented creativity, and the infosphere. Then we have Fundación Épica La Fura del Baus, which is a research center in advanced arts from Badalona in Spain. And we have RCR Lab A, which is an open architecture laboratory space for creative research from Olot, Spain. We have PINA, a Slovenian cultural and educational non-profit organization dedicated to fostering sustainable development and empowering communities. And as part of that, the HECA Lab, which is a cutting-edge research lab focusing on many things, and in this particular instance, their experimental spatial audio unit. We also have In4Art, a European-focused independent research and development organization for artistic experimentation and responsible innovation from Rotterdam in the Netherlands. And last but not least, the Media Solutions Center Baden-Württemberg from Germany, a non-profit association promoting innovation in the arts and media industries by facilitating access to technologies and expertise in high-performance computing and visualization. And they are also coordinating this whole AIR project. All of this is funded by the European Commission and their Connect Directorate. So that was the long part. Now we come to the actual business, the AIR Residency Garden of Entanglement. So all of our 10 artists have to participate in knowledge transfer sessions to bring the insights gained to other disciplines as well as the broader public. And this specific residency is exploring how human movement influences trees. How do trees resonate and vibrate in response to us? The art-science collaboration will produce an artistic installation raising awareness of the topic of tree dynamics and environmental awareness in general. But I don't want to talk about it too much. And without further ado, let's dive into it with Hien and Daniel as they explain their artistic vision and process.
Yes, so today I want to once again I want to talk about the artistic vision and process of this project, and on the second and the third part, Andrea and Susanna are going to walk us through the scientific insight, the experiment, and the data processing and visualization possibility. After that, Daniel and me, we're going to talk about our installation concept in the AIR Festival in Barcelona. Right. I think first of all, I want to once again talk about why I start this project. What does it mean to me? So actually, I think one of the reasons was that I've been looking out the windows and saw the tree out there. That's the view from my window, and at some point just thinking that tree like witnessed so many things, like kids going to school, they are very loud, or cars driving, passing by, or just like you see in the pictures, like just a giant construction machine just coming through and whack all the street on. So it's for me just to see like for me, I think that it's just incredible for tree to witness everything, to like see everything, and I just wondering how tree like perceive that, and scaling that up. I'm thinking about how tree being a part of the city, of the urban context as we live now, but because of its nature of the being, it's kind of not being silent and not perceived much by us. And but it's clear, but trees are clearly very important in our current context, especially with climate changing. So that's why I want to start this project from a very childlike idea to imagine or to understand how tree would think or would feel, and to see like how we can understand tree, and like applying that into the urban design as well as into my artistic development process. So this is the research questions of this project. In the first place, like we already mentioned, this project is to exploring the resonance between the trees and the human activities in the urban context. And I want to focus on trees, how tree would perceive and record the human activities around them. Another point which I'm considering to develop this project in the further context is to examine how these memories and the perception of tree would be translated in the scenario where our civilization change, like how tree would remember about us. And this is like to kind of a reflection to our connection to tree from the point where we are now using many technology and digitalization tool to understand tree as well as nature. Right. So for this, the realization process includes mainly 4 points. The first is to research and conduct an experiment to understand tree reacts to humans through tree dynamic sensing methods, and here with accelerometers. I will explain later why I chose this, and another point would be that I understand and that this for this goal of this project, I have to combine several scientific approaches, not only with the tree dynamic sensing, but also with the chemical and biology aspects. So that's why I also plan to conduct further research and interview with other experts to understand how tree might remember this interaction over time and in their mechanism. Based on this data analysis, and on the scanning interview, we want to create an installation which acts more like a pilot one, to give an impulse and to connect the audience with the hidden dynamics with the perception of tree in the urban, in the city. And the final point would be like for the future consideration to find a way to contemplate how tree and how the memory and legacy of human civilization would look like from the perspective of trees. In a big picture, I think this project can have potential impacts on several layers. So from the scientific understanding, I think this project which we are doing now can provide another approach on understanding tree health and how we can examine or predicting trees development in the urban context, and this can help back into the city design or city planning. And for me as an artist, since we have been working with the data we conduct from the project, from the experiment now, it has already given me like a new forms or a new understanding how to create the sounds and also how to translating several data into movement, which I'm going to talk more about that in the later part. And another thing is, since this project was gonna be presented as an AR installation, and this open format of the AR can make this project a very good one to adding more further scientific and artistic exploration in the future, and the interactiveness and overall the interactiveness in this project can further foster more another educational impact on, especially on the audience who has not so audience to understand more about the trees health and tree reaction in the urban to human and in the urban environment. Right. So so first of all, we start with the accelerometers and we contact Andrea, and then we did an experiment campaign in Florence, and here we are putting several accelerometers, also microphone and 3D scanner around a tree. And we did perform several stimuli on the trees to see how it's exciting and how the tree would react to that. So the reason for why I chose this method would be because of the high sensitivity accelerometer, which can capture the very subtle change in the dynamics inside the tree. And I think that this could give me a first a first understanding into the topic. So this is like the experiment setting that we did in Florence, and as you see that we the red one are the accelerometers, and we put like 3 of them, 1, 2, 3 on the tree trunks, and 4 and the other 2, the number 4 and number 5, on 2 branches. We also put another accelerometer, the number 6, on the ground, which is a little bit further from the tree, but closer to the street where the car is passing by, because we want to measure how the vibration from that ground translating into the position where the tree is standing. We also put contact mic on the tree. On the first day, we put that on 2 different branches, not the one with the accelerometers, but on the second day, we put it almost on the same position as the accelerometers on the branches. We also use an iPhone with the app Decibel to measure the air pressure at the point near the tree. And on the second day, we also put loudspeakers and subwoofer around the tree, and we play several sound and frequency through that. So this is like the setting. And we, we, in addition to measuring the change in the tree with ambient, through ambient, like through wind or car passing by, we also perform some performance around the tree. For example, like we're touching different parts of the tree and mostly focusing on the part where we put the accelerometer on. We're also jumping and talking around the tree. And this is based on what we want to recreate the situation, how a tree in on the street like would experience, like with people walking by or kids or people shouting and so on. In addition to that, we also perform 3D scanning on the tree as well as on the environment around that, which is the University Florence Park. And here, I got the 3D scanner from Uber, and thank you for lending me. And yeah, so it was my first time working with that. Actually, there's some challenge, but in general, I'm excited about the result. And as you can see here is, can you see the video running?
Yes.
Yes. So here you can see like the first processing from the tree scanning, and you see that the figures of Antea and them sitting over there, and me walking around in the fragmentation. There's surely have some missing parts since this was like the first time I'm operating this, but in general, for me, it was very exciting to see how we can translate the scene into a virtual environment. And for the missing part, we are also now using the Polycam and other pictures formats to adding or fixing the missing parts. Yeah, right. So now I think it's good that we talk about more in details about the experiment in Florence and how the data analyzing and processing has been going, which Andrea and Sudana are going to be talking about. So I'm going to give the word to you.
Okay. First of all, I want to thank you for involving me in this interesting project. I am a civil engineer, and I'm working in a laboratory of the University of Florence on the Department of Civil and Environmental Engineering. I'm working in a laboratory which is the structural and construction material lab. So we used to work with civil structures, cultural heritage, bridges, bell towers, and so on. And in our activities, there is one of the main activity is related to structural monitoring. And in the field of structural monitoring, we can split two main topics, which is static monitoring and dynamic monitoring. Here, there are some pictures of some works we did in the last few years with in the field of dynamic monitoring. And again, this is something that we used to do for civil structures. Can you go to the next slide, please? What it happened a few years ago, it was that the forestry department of our university contacted us in order to try to start a multidisciplinary project on the tree failures in urban environment. And so we, because this is a serious problem, especially due to the increased number of extreme events on Europe, we can say. On Italy, but on the whole Europe, this is evident. And so we started at in a first approach by working on a risk analysis procedure, and so trying to identify the main elements of the risk related to tree failures in urban environment. And one of these elements was the tree vulnerability. And so we realized that it was necessary to approach the tree vulnerability as we do with a civil structure. So studying its mechanical behavior, both in terms of static behavior and dynamic behavior. So we tried to approach to the measurements on a tree as with the same methods that we use for a civil structure. And we realized that the topic was really complex. First of all, because a tree is a living structure, and then all these measurements are measurements that we can do only in open field, so on site. And performing measurements on site, it means that all the environmental parameters, temperature, humidity, and so on, are affecting your measurements. And this is one of the points that we discussed together with Hien and Tam before, why we were planning the experimental campaign in Florence. Of course, an ideal condition is when you can do both, so on-site experiments and laboratory experiments, where you are in a controlled environment. So we could say that we did this first step with on-site experiments, as Hien showed us. And okay, this paper that you can see here was a sort of a link between Hien and me, and it is thanks to this publication that we connected. We started sharing some ideas and started the idea to do an experimental campaign here in Florence. Here there are some preliminary results. Well, we measured with sensors that are accelerometers and that are able to measure accelerations. The sensors were seismic accelerators, so very accurate sensors. And they were placed in on the tree trunk on 3 different directions and on the branches. So the idea was to try to fix enough sensors in order to capture different movements that the tree can do.
Yeah, just showing back to the picture where you can see how the accelerometer was placed on the tree.
the main a good picture to show the main setup. So the idea was to be able to capture different movements, so movements of the whole tree, of the trunk, but also of some of its components, like the branches. And here we can see on the left side, for instance, a very small accelerations, and on the right side, larger accelerations, because on the left side we were measuring vibrations along the vertical direction of the trunk, while on the right side we have a signal of the vibrations of a branch, of a transversal motion of a branch. We tried to approach to these measurements in a very, let's say, trying to, sorry, we are measuring the response of the tree. Okay, so we are measuring the output, the behavior of a tree when is forced by different inputs, okay, or stimuli, as Hien called. So we tried different kind of inputs. The ambient vibrations, like here we have two results of accelerations under ambient vibrations, which are micro tremors, wind, car passing by. So inputs not it's clear and clearly identified, but so randomly distributed that can be assumed as a white noise, no, something that is acting on a very broad range of frequencies. And then, can you go to the next slide? Which different kind of inputs, like walking around the tree, jumping around the tree. And in this case, for instance, we see that the signals on the left side, so the vertical motion on the trunk was higher than the acceleration that we can measure on the branch. So also the way the vibrations are transferred along the tree are another interesting point. I don't know if it's enough for this part. Maybe we can leave something for further discussion and for the final discussion. But obviously we were measuring the mechanical response of the tree. Obviously, the tree as a living creature has its own way of adaptation to different stimuli, but the way a tree changes its characteristics in terms of adaptation, it needs a very long time respect to our measurements of a few hours. But what we can do to appreciate the changes and the adaptation of a tree can be, as we do in monitoring, to do the same measurements after a certain amount of, so after 6 months or after 1 year, to repeat the same measurements with the same inputs and to see if the response are changing or not. So, okay, I think for this part I explained more or less what we did. Yes, this is just a quick. I just want to show you briefly another part of the post-processing, because we planned the experimental campaign, we did the measurements. Hien and Tam were in Florence for 1 week, because these kind of measurements require time. But then there is the post-processing, so the data analysis, which is another important part. And the idea was, for instance, to try to starting from the acceleration that we measured to convert this acceleration into displacement, and so to have for each point where the sensor was fixed on, and for each direction, the sensors were recorded simultaneously, so we could recreate the instantaneously movement of the tree during our recordings.
So hello everyone, my name is Susanne Malheibus and I work in the visualization department of the HLS, and I'll continue talking about the post-processing like Andrea just did, but I will focus on what we actually want to do with the output of the post-processing to incorporate it into the art installation. And this is very much just the first concept, so we would really like to hear input and feedback on it later to help us improve the final installation. I'll just start with a brief introduction. So the High Performance Computing Center in Stuttgart is part of the University of Stuttgart, and we have one of the 3 fastest supercomputers in Germany. And you can imagine a lot of researchers come to us to perform their calculations there, especially simulations in all kinds of fields of study. And what we do is help them communicate their results, but also help them explore their results by creating visualizations. And we mostly focus on 3-dimensional visualizations, so virtual reality and augmented reality visualizations, because most of the times the data that we receive is in a 3-dimensional domain, so we think it makes sense to also look at it in 3D. And another thing that is important for us is to be able to interact with the visualizations. You can see in the middle video, for example, to help the researchers just navigate through their data set. Right, for this project, what we got from Andrea, no, you can keep, you can go switch to the next slide, please. Yeah. Thank you. Basically, what we received is the results of the experiments that the artist team and Andrea did in Florence. So we got the acceleration from the accelerometers and also the audio signal that they captured with their phones. And another thing we got is the experimental protocol, which is just an overview of all the different takes they did. Hien already explained it at the beginning. We had had a baseline take where we just measured like the external forces on a tree that you typically have, like the wind, for example, but also some excitements like touching a tree, shaking a tree, walking around a tree, talking around a tree, and more control things like actually playing music or frequencies to the tree. So we got all of this input and created a post-processing script with it, and I'll just go step by step through what we are doing in that script. So please go to the next slide. The first thing we did is relate the events that the experimenters took during the experiments to the actual signal, the acceleration signal, and that you will see on the next slide. This is one example. So this is the very first take, the ambient take. You can see in green here the acceleration signal of one of the 6 accelerometers that they captured. And as a first step, we just added the events from the protocol into that. So we have events like the wind, like a light breeze, a car passing by, things like that. Why did we do that? The idea is that in the end, for the art installation, we want to make it interactive so that the user can later choose which stimuli they want to see, and based on that, the response of the 3D model of the tree will react in a way. Another thing we did is, because we had 2 different signals, the signal from the microphone and the signal of the accelerometers, we first had to also synchronize the signals. And for that, Andrea and Hien, basically, they just clapped at the beginning of each take, so that in the data it would later appear as a peak. So what you can see on the top left, for example, where I put these red crosses, that is basically the peak in all of the acceleration data. So here in this plot, you can see actually all 6 acceleration signals that were captured during one take. And you can see that most of them start at the beginning. We have one outlier in the end, but because all of the accelerometers are synchronized in themselves, what we did here is basically just cut all of the signals to the very first peak that we encountered here. And for us, this is the moment in time that they did the clap. And then on the top, on the bottom left, you can see the synchronous signal of the accelerometer. And we did essentially the same thing for the microphone signal. So you can see here the peak at the very beginning. That would be the time where they clapped, and we just cropped the data to that point to get the result at the bottom right. This is something that Andrea already talked about. So we have the acceleration signals, but we actually want to get the positional data to see how the branches and the stem of the tree were moving in time, depending on the stimuli that was put on the tree. So if we go to the next slide, you can see one example of this. This is just another take. We start here with the acceleration signal, as you've seen before. This is again of one of the accelerometers. Then we integrate and filter it to get the velocity in the middle of the plot here. And we basically repeat that to get the positional data. Of course, it's a tree, so the movement is not very large. It's only a few millimeters, not even that sometimes. But the idea is to use this positional data to later then animate the 3D model of the tree, which Hien will also show you in her next part of the presentation. We also wanted to have a more scientific component, so we wanted to find a way to kind of compare the different takes with each other, and for that we decided to do a frequency analysis. So what we did here is basically just apply a fast Fourier transform to get the frequency spectrum for one of the takes here, and each column is one of the accelerometers. This is still a work in progress, so the next step would be to do this for all of the takes, and then just first compare the same accelerometers across various takes. So how does it differ depending on the stimuli, but also compare within one take the 6 different accelerometer signals. So how does the position influence this? And once we did that, and we hopefully find like an interesting response or an interesting change, we also want to incorporate that in the art installation. But yeah, we kind of can only think about this once we actually have some results. That makes sense. All right, that's it from my part. That is where we are so far. And I'll hand back over to Hien.
Yeah, thank you, Suzanne. So yes, I'll continue with the concept for the installation. And like I said before, this installation, as I see, is more like a pilot one to give the first perspective, like an impulse to the research, to the topic we are conducting, we are doing. And next slide. So the idea is to create a physical and also a virtual installation, and to bring the audience into basically into the space inside the tree, like to be inside the tree. So the physical one, which here you can see, there's a platform. There's the platforms, and also we also want to play with the height, so we also create like curtain around the platform, which imply another way the skin, the bark of the tree, and on the curtain, the data which we took from the experiment, we print on that. The reason for that is after a while, it's fascinating, but also intrigued me a lot to realize that the subject of my research is the tree, but actually what I've been working on is like yeah, it's like a folder full with data and looking at that all the time. So it's like a reflection from my side to see that actually when our subject is a nature or like a living being, but what we're looking at is more like we use technology, we use data to looking at the matter. So that's for the curtain, and the platform is acts like acts more like a space for people to step on or to live on. And as you see here, when people are away, not on the platform, they can see if they have the device on, they can see the AR tree, the tree with the setup we are doing. And as soon as they step on the platform, they can see the inside. They're gonna be like brought into the inner space of the tree. And next slide. So yeah, this is like the intended measurement of the installation, and for that I want to hand it over to Daniel. Could you talk about the floor, the planning for the floor for the
Sure.
platform?
I mean, from spatial design wise, we try to configure a setting that will attract people from the outside to the inside. And like the curtains, they act as a kind of barrier from the outside to the inside. They also act as a replacement for the bark of a tree, because the AR experience will be inside of the tree or underneath the tree. The flooring system is kind of a cut through, a sliced tree. And we try to recreate this in a physical space, but in a very reduced material wise. If we go to the next slide, you can see a mock-up for the installation. Basically, we try to use material that we will not have to transport to Barcelona, but that can be bought on site or in the city, easily carried or transported to the place. And then we have devices that we will bring. In fact, only on the right side you can see a bass shaker with a speaker cable connected to an amplifier that will power the device. The whole setting is meant to vibrate, and we will achieve this with devices that are actually not invented for art installations, but they come from the car tuning scene, or as Mauricio knows, he also has one of these devices underneath his chair he's sitting on right now. You can also like bring audio input through these devices and actually feel the sound, and that's what we wanted to replicate here. So the data will be felt through the body. You can basically stand on the setting, you can sit on it, you can lie on it or touch it. So several ways to feel the inputs. And the setting incorporates active parts and passive parts because of the shape you saw. It's actually pretty, it's pretty natural in a way. And we can actually only buy straight panels and then cut them. Means we have parts here that are actually passive or active. Please go to the next slide. Yeah, on the right side of the right picture, you see an active part and a passive part that is actually only connected with pieces of wood. Works pretty well. the whole thing is disconnected from the flooring through buffers. And basically here you see some kind of very thick fills. I'm not sure what the English word is. Some kind of wool material that acts as a barrier for the sound. We're gonna cover the whole thing with a mixture of different fabrics to create certain layers that will be I mean, the approach is to have a visual aspect of the whole thing that acts as a eye catcher, but also we want to create different layers that you can not really understand if you don't get closer. So visually, this also has an impact on the audience. Actually, I'm not sure what else to tell.
No, that's great. Thank you, thank you, Daniel. So as you see, here I lie on our testing platform to feel like the tree breathing. So this is what I also want to talk about, that we are dividing the data into different layers and then putting each of them into different parts. One part we're gonna put into the floor, which gonna direct the how the floor vibrates and how the shaker devices run through time. I'm going to talk about that later more. And the other one would be to direct to put the data into sound, and here we also gonna have 4 loudspeaker putting above the installation to inviting people into the space. The other one is to using the data to create the movement and visualization in the AR tree. And so I'm gonna jump to this place. So the plan is when you lie on the floor, like I did here, and you have the device on, you are basically be inside the tree. And as of now, it's an open, it's kind of an open space. The whole space that you see here is what I took from the LiDAR scan with the lasers with the 3D scanner. And I'm planning to create like an interactive, like an adventure, more like a story inside the tree to let people traveling or move or go into different parts of the tree, which now I'm planning like 3 parts, which is 1 is the tree trunk and 2 is the tree branches, and on the position where we put the accelerometers. And so when people go into the different part of the tree, they can see some videos which you can see here, explaining the story or the process research, and also based on the data we're putting in, they can also see particles emitting. So the particles are the 3D scatter plot we created from the acceleration data. And another aspect is the whole space will be somehow like it's like a creature, like it's breathing and moving. And we also want to let the people to have the chance to choose the different text. For example, when they go to the branches, they can choose to see how the branches react in the ambient, in the wind. And when they go to the tree trunk, they can decide if they want to see how the tree trunk react when we're jumping around the tree. Currently, we are focusing on doing like 2 texts for this pilot installation. This is how we are trying to translating the data into like trees breathing. Here I can play the video. Right. So yeah, we scaling up the data because everything was very subtle, and it's resulting now that it's breathing too quick. So it's also one thing that we're working on, like to fine tuning that, and based on the data we're putting in. Here is some tests I did to test the tree in the real environment. So pardon me for just being in pyjama, but yeah. So we can see here. That when people having the device on, when we put the app on, so they can see basically the tree in that scale, and they can moving around. And it would be great I think it would be great if they can also create their own video or photos, which they can save and share with other people. And as they're standing near to the tree, so they can see some interaction like that. Now I'm going to talk about the composition of the sound concept. And as I said before, we are like putting we like dividing the data into different layers to create the sound, and to also let the sound be the one to connect the physical, the flooring, the curtain, the physical one with the virtual one, which is the tree. We're also facing some challenges in sound data sonification, sometimes kind of feeling like repeating, or there's not so much dynamic inside that. So we want to take a more artistic approach into that. We choose several instruments, and we use the data to control the pitch. So here is the mind map, how we are going to work with the data. As you can see that currently we are working with the touch on the right. Above you see touch, step, run, white noise, or cars passing by. This is the events that we are planning to try with the sound. Currently we are only working with the touch, and that means that's the part where thumb was touching like the tree. And so we get the data, and then here we have we divide the data in like six layers. It's actually like six accelerometers. We have the data from 1 to 4, which we're gonna use that to change the pitch into samples. And the data 1, the tree trunk, we want to translate that into the vibration of the floor, which means that we using the lowest frequency part, and then we create a map to direct the device shaker that they will run each time. So currently we are planning for the 8 channels for the floor, but it's still to be discussed based on how we building and how big the floor gonna be. So that means that at that time there's gonna be like a dialogue between the vibration of the floor to the loudspeakers which are installed on the ceiling above the installation. Through that loudspeaker, we want to put the data, which we translate that into several samples using different instruments like cello, erhu, also a string instrument, and kalimba. And in the data number 6, we will translate that into a vision in the AR, which gonna synchronize with the sound with the sound running into the loudspeaker. So that's the manual, and I'm gonna show you a very short test how the moving inside the tree combined with the sound would hear like. And so can can you hear some sound? Once again?
Yes.
Oh,
Yes.
why doesn't play? It's playing. Yeah, yeah, and so what we are what we're doing now is that we're currently also trying to implementing the interactiveness into the AR to let people move and have different options to switch on text or like to move into different position. We are also currently in talking with the Epica Foundation, since they tell us that they also have an app which can help us. So this is to be updated after this Friday, since it's going to be our first talk with their CTO, like their technology chief, I guess. Yes. And I'm also reaching out to, as I said before, so a part of this project is to have an open layout AR to adding videos with telling the story of the project, but also how the project can develop further. And for that, I'm also reaching out to several biologists and other scientists from other fields like biology, and currently I have a reply from the University Stuttgart and also from the Jena Max Planck, and I also plan to put the interview of them, and also with the editing from our process from here, sharing with Susanna and Andrea to put into the videos inside the tree. So yeah, that's what we are working on. And yeah.
Oh, thank you. Yeah, so yeah, since we're on the final installation concept, like in the beginning and now in the end, you were talking about the installation improving over time. I guess you're having plans on what to do after the residency. What improvements do you imagine? How would they serve the greater educational purpose of this project? Maybe you can talk a little bit about this. And Daniel, you're more than welcome to join, of course.
Yeah, sure. So of course, as Susanna and Andrea like talked before, for example, with the visualization, we are currently focusing on doing the interactiveness on 2 texts. For example, like it's very limited based on that we have done several texts with several inputs on the tree. So that's also what I'm planning to work after this residency, like to keep on developing the AR, and also to further conduct the research. As Andrea mentioned, that we just done the testing on the tree on 2 days. We did, and we like in one campaign. And actually, we in order to see something, we need to conduct the experiment over a long time. That revisiting it after 6 months, for example, to see how kind of like how those perception form the memories and how that story inside the tree. So that's what I'm also want to do in the future after this residency. Looking for funding. Yeah, and I'm also currently talking with Leonie Fischer from University Stuttgart, as also the director of the biology department in Jena, Max Planck Institute. Especially the Max Planck Institute, they mentioned that they could also imagine to perform some experiment to see how the tree cell response to the stimuli we do. So it's like going like it's a direction of going deeper into the tree cell, which is and looking at on the molecular molecule level. Yes. But yeah, yeah. So, and I also hope that I will be able to bring the installation and the work to other contexts, such as museum, galleries, and or galleries, or even like in the park. In the park, as I feel like yeah, maybe we can after this point we can find a way to create a like a workflow to create, not a workflow, but I mean more like to how to sonify the data, the acceleration data, and to make that into a meaningful composition. And yeah, it could be a forest with sound, or it could be a park with sound and music.
Yeah, cool. Since you're on the sonification part of it, we have Maurizio with us, who hasn't talked in this presentation yet. So I would like to get your perspective on the sound part of it all. How does it complement the other research you do at HECA? What was the process like for you working on this particular project?
Yeah, thanks. I think the biggest challenge for me was to imagine something outside the spatial audio facility that we have, that to focus on how to develop an application that will use the data and send it to a process or different forms of manipulation of a sound. That, in my experience, is not very easy. Like sonification is one of those elements in music and technology that have not delivered something that is meaningful yet in terms of composition. So that's very challenging. And one of the things that it was my main focus, it was just to orientate the platform, the programming platform that I know, which is Max, and Tam also is familiar with that. So we were developing different kind of ways to parse the information, send it to different oscillators or synthesizers. And at the end, the decision, my function in the project was just to orientate, basically, to guide where to go, what kind of tools I know they're available for this, from hardware to software. And I think they found a interesting way around to this sonification area where things eventually, I think one of the potential uses is how to send them not only in stereo system, but send them into a multi-channel array. That could be very interesting when you have augmented reality headphones that don't exist yet. One of those things that are very much needed is how to keep the ears open and experience beyond binaural the sense of space with a full, spherical representation of the sound field, which is not yet available. And that would be interesting to see. I mean, that is not fully implemented in the HRTF, the head-related transfer function is not solved, let's say. And that's something that could be very interesting to see in these kind of projects. How does this can be more meaningful when you position the sound with an intention, not as an effect? How to just move the sound can be interesting for a minute, but after that it's just like reverb. It doesn't bring any ideas. So I think in these kind of projects, it will be interesting because you have a spatial thing that it has different areas. So stereo is very reduced, but it's something that probably in the future will be able to help a bit.
Uwe, do you have any ideas on how to help with that? Because I saw you shaking your head a little bit. Oh, was it
No,
something else?
I don't have anything that helps, I guess. I mean, there are microphones that allow you to hear there are headphones that allow you to hear the external sounds as well. But the quality is an issue, I guess. So there's no good solution to that problem. Yes. No, but what I would have a question to Andrea. Is he still here? Here. Now I see. Stupid. So I wonder whether you have other data like ultrasonic scans of the structure of the tree. I've seen you have like CT scans from the microstructure of the tree, but I think for failure analysis, what is your main task? The overall structure of the tree, whether it has holes and how the wood structure actually is, would be very interesting. And that would be also a nice thing to visualize.
Yeah, if I have well understood, the question is about other kind of measurements on the healthy of tree. Yes. Well, as we discussed about this with Hien, and for instance, there is the idea to improve the measurements also by considering some biological parameters, because obviously with the accelerometers we can only measure the tree movements. Okay. There are a lot of other tools used, for instance, to see on the leaves if depending on the I don't know how to translate it, but looking at the leaves and understanding if the tree is healthy or not, or there are some kind of radars to visualize the roots on the not so in deep, but on the first layers above under the ground. There are other tools that are used on the tree trunk in order to understand, for instance, how when you create a hole on it and then you can do some measurements on it. It is a very wide field, and honestly all these techniques are more are used by our colleagues of the urban forestry department. So I never used them. The only thing we are doing now is combining the standard static tests with dynamic tests.
Okay.
And in this case, the idea was to use the same approach of dynamic testing with Hien, and just to link something with the what was saying Mauricio. Another challenging issue is that the frequencies that we are measuring and the frequencies related to the tree movement are much smaller than the frequencies that we can hear with the with our ears. So a challenging point is using those data, because we are working in different frequency bands, and there are only some overlapping bands at very low frequencies for our ears. But we are talking about 10 hertz, 30 hertz, and we can reach up to, yes, 100, 300 hertz something. But obviously what we can hear with and what we want to play with some speakers is in another range of frequency band.
Yeah.
So
yeah, for sonification, that's an issue, but you can always transpose sounds to make them hearable. But for visualization, that's, I guess, not much of a deal, because there we can visualize anything. You don't have any ground penetrating radar scans of your branches, of your the roots, for instance?
No,
you don't.
We have in another department we have an interferometer. And we can try, if you want to, for further development, we can try to contact them and to see if this kind of measurements can be done.
Yeah.
Why not? Why not? A very important point that Suzanne stressed when she was talking, it was on the triggering of different measurements. And in our case, during our experimental campaign, we were not measuring only the accelerations, but also with contact microphones and with open field microphones, but with two different systems. So in our case, we found a solution of a physical triggering by clapping our hand or doing a huge step on the ground. And so having different instruments, having different tools and doing different measurements simultaneously is super interesting, but it's quite challenging to trigger them. We have to maybe to do some take and try and error, so it needs time. In this case, it was easy. I don't know if with an interferometer can be as easy as it was with the microphone, for instance.
Cool. And one question to Hien. What I did not see in your piece so far was a reference to tree failures, the actual subject of the research been done on the trees. So I think that could be a nice addition to reference that in the art piece as well, in some way. Not only the motion and the sounds, but also the actual goal of the research, the failures.
You mean the tree failures, or you mean?
Yes. So by the way, do you also do destructive tests? So if you had sound of a breaking tree, that would I think add some quite dramatic impulses.
Unfortunately, we did not do that yet.
So yeah. That means that we still can do that. But thank you, Uwe.
Okay.
It's a good idea. I just want to ask, like, okay, so you mean tree failure, for example, a tree breaking or a tree falling down? That's what you mean?
Tree branch breaking, that's the failure modes, right? Either root failure, the whole tree collapses. You probably have a hard time capturing that event, but breaking a tree branch is easy, I guess. And I think it might be interesting to record accelerations and sounds up to the point where it actually breaks, and you might hear foreshadowing. That's the beauty of wood, except compared to other materials, wood actually is creaking and making noises before it fails, and you can leverage on that to detect it before it's too late. And that would be a sound related issue, and it would show the actual research that's been done, or the goal for the research.
Yeah, thank you. That's a really great idea. I think on the sound aspect, we certainly do that and do the sound recording. On the accelerations aspects, this is clearly like depending on this might depend more on Andrea's side and availability. Andrea, what do you think?
I know that with our university we have a site which is an open site where we can also test a tree up to the tree uprooting. So to to do in a controlled experiment, a tree rupture.
Okay. So you did that already, or?
No. Now we are only measuring these trees, and the idea is that we want to measure these tree and monitoring this tree by creating some damages, some on the tree, simulating a illness or I don't know, a human activity. For instance, if we are in an urban environment and there are some works on the street and you are cutting the roots of a tree. So, but I think we can plan this. Maybe it takes some months, but we can plan this.
Yeah, that doesn't need to be for. I think we're running out of time, right? But it would definitely be nice, but if
I
it's
think
a time issue, we don't need to force anything like that. But still, I'd like to see some artistic reference to the actual subject of the research. That would be cool.
on the tree failures. But I would like to change a little bit the perspective, the point of view from a dangerous element to a vulnerable element, which is different, because the idea must not be I will cut all the trees in an urban environment because they are dangerous. The idea must be the opposite. So I will take care of all the trees because they are vulnerable elements.
Okay.
And of course, if there is a too old tree or a ill tree, I will replace it. But I will not be scared of the tree. I will take care of the tree. This is something I would like to do with this kind of approach.
That's fair.
And yeah, also that's a very interesting field, because probably could be good wrapping up to know from Hien and Daniel if there is any philosophical background of a project or the statement with the installation. What do you expect visitors will achieve or get out of the experience?
Yeah, so I think first of I think for me, Daniel, do you want to start, or
I can start if you want.
Yeah,
Like
please.
installation wise, I think the approach should be to create an interesting format that will attract people into this very, very sterile and dry topic of data and how the trees are there and what kind of influence humans have on this. Like, to be honest, many people are not interested in it, and our task is to create something that is attracting people into this topic. So it should be visually approaching and interesting. It should be audio. On the audio aspect, it should be interesting. The installation should be something that is not understandable on the first view, and this is our approach to this. So you can actually, when you get closer to the installation and touch it and sit on it, you get step by step, you get more and more information, and this is the approach here. Yeah, I think hopefully that answers your question.
Yeah, I think it's related to the motto of the project, the making visible the invisible, and this way that makes physical, the haptic, the sound. There are many things that align there, or the things are happening beyond our senses or our way to interpret reality.
Yeah.
By the way, just one thing, the subwoofer, I remember something. There is some rotary subwoofer that allows you to produce from 1 to 100 hertz, but it's incredibly damning. I mean, it's something that's very expensive, it's very experimental, but it can physically damage structures.
Yeah.
So that we talk about it, I think, and we found it, but it's not suitable.
We researched it actually and figured that it's much easier to create a surface with these best shapers. And I mean, the aspect of bringing audio waves to a surface that is starting to vibrate, I still think it's super interesting. But it's much easier and not so complicated to just install something in the flooring system.
All right.
Yeah. Because you would actually anyway have to create a flooring system that can vibrate if you want this thing you mentioned to influence the flooring system to vibrate. So why not actually like making the flooring system vibrate itself? That was my thought, because technologically it's so much easier. And on another level, I also have a question for Andrea. About the research of the forestry department that is actually interesting me a lot, because trees are living beings, so they use water that is transporting nutrients and so on through their bodies, and through this kind of process they probably change their electrical resistance. So I was asking myself, is there any technology available in the forestry department that could be used to measure these resistances depending on the time of the day, the sun influence, rain? Like, I mean, I assume they change their resistance quite often, and I can assume that we can also datafy this information, like, or use it to create audio and visual experiences. And also, I think this can probably be used even more precise to actually understand the quality of a tree, like if it's healthy, if it's not healthy. I think I mean, that's my personal view. The acceleration data is very interesting and complex, and you can transform it into very different measurements like speed, movement, and so on. But we had this conversation with our mentors, and there was this idea to actually implement more measurement technologies into the whole thing. And I think you can really like create more valuable research with this kind of technology. Even if it's not your main focus, I highly recommend you to work on this.
Yeah, thank you very much. As we discussed it together in another meeting on this topic. It's an interesting topic, and obviously you have wood, you have water into this wood, and for instance, some hygrometers, some tools used to measure the water content into the wood works in this way. So there are 2 points. They use a power supply, and then they measure the resistance of the wood, and then they can understand the water content.
Yeah.
And there are other more let's say experimental setup. So this is a quite common tool, but there are also some more experimental, more let's say sophisticated tools. This can be something we can try to use the tools like this. So why not? I am available to try also to use also different tools, because in this case, as I told also to Hien in many occasions, we must know the limitations of our sensors, of our measurements with the accelerometers. And obviously, we need a complementary set of measurements. So different tools that used together can give us a clear idea. So of course, in the future, we will consider also the measurements with electrical pins, or we'll see what we can do. Yeah, of course.
Yeah, sure. Awesome. I think also like a challenge for the future would be like to combining those different sort of scientific approach, as you mentioned, with the electronic, or as I'm also exploring that with the chemical response. Yeah, I think that would be a very exciting path in the future to actually to combining all those approaches together. Yeah, I've so recently I've also been working on extracting the CT. So I, as you may know, I last year I also did like a CT scan on a tree, but like I had to cut down the tree and put it into the CT scan, and the image was like, and the image with that that clinic gave me was just JPEG. But now I have been managing to extract from the JPEG into the 3D model. That's still the thing is like that approach that we need to cut down the tree might not be applied to a living tree, and to perform like CD tree on a living tree, that means for what I've been researching, is kind of expensive, and that's one company in the Sauerweih company. What they offer is still way too expensive, and again, this also I don't know, but another thing that I would want to explore is to work with ultrasonic tomography, since I think it's more easier and less expensive than CT, and many Baumfläger, they're also using that to determine tree health. But I also want to ask, did you have experience on that for the visualization? Because from what I see, the image we got from that was just showing the showing the hollow inside the tree. Or did you have experience with the ultrasonic tomography? Maybe that's the question for Uwe. Yeah, did you?
Well, for the visualization, it's if ultrasound imagery is taken correctly, it's not an issue at all. It's the same as a CT scan or MRI scan, but you have to have ultrasound scans with a known orientation and location, and that's often not the case. We do get these from scans of fiber reinforced materials. That's often done in aerospace industry to non-destructively test wings and propellers and the like. And there the visualization is not an issue, but this is a little more tricky than just doing a visual ultrasound scan, which gives you one slice at an arbitrary position, and you look at this, analyze it in 2D, and then you take your conclusions. So doing a 3D visualization requires you to have real 3D accurate measurements of the position of your ultrasound imagery. Otherwise, you can only basically do 2D visualizations, but that's easy too, right? That's a set of images. That's a movie that you can play back. So you should also be able to use that data if you get some.
Yeah, thank you.
Okay, maybe looking at the time, do you guys have time for one more topic before we go off? Because like the general idea of STARTS is, of course, the collaboration between the artists and the scientists. So I would like to hear a little bit of input from you on this. Maybe we can start with Andrea. It has probably been your first time doing such a collaboration with an artist. What's your experience with that? What did you gain? How would you describe that?
Thank you very much for this question, because it is something, and I want to say that I was impressed by the scientific approach that Hien and Tam had from the beginning of this project. I was surprised, because sometimes in my experience it could happen that you work with some engineers that are less organized and less prepared on what they want to do and how to do. And I said this to Hien many times, and I was impressed about this. And at the same time, I was really I like music, I like arts, and I was, let's say, happy to see that project like this one could really mix science and art. And obviously there are, in many occasions, an artist use the science without a full control. Let's say just doing something which from a scientific point of view is interesting, but without considering this aspect. In this case, we are paying a lot of attention on this aspect. And I think this, even if at the end, even if during the installation, when people there will be there and will see, hear the installation, even this part will not be all so clear to the audience. It is interesting, this work, this preliminary work for for the installation. That's my point of view, and a very positive experience.
Great, thank you. Would you say you like your research benefited from the collaboration, like through the new perspectives that came in? Could you reflect on this a little bit?
Probably yes, especially with the work we are starting with Susan, because obviously now that we have data, we can work a little bit more in deep into the post-processing analysis. And however, the point that Daniel was stressing before, that it is important to try to communicate some crucial topics to the community. This is another point very important for an engineer, because or for a researcher. You mean what we are doing is not for ourselves, but it is for the community. So even if in this project I will not have a direct scientific upgrade, but I will have, for instance, I will communicate easily to the audience, to the people, what we do. This is a super good goal.
Cool, thank you. Yeah, the same question goes out to Susanne and Uwe, maybe. Maybe you can even touch on like the more general sense of how you imagine these art science collaborations in this and in other cases, because I know you have more experience with it. How do you think this works, benefits anyone?
Maybe I can start and then we can chime in. So I think one of the biggest challenges is in the beginning is that the way we usually work, there's already a data set from the scientists and they just give it to us, and then our work really starts. So then we start visualizing that data set and work together with the researchers. But for this project, in the beginning, there wasn't really any data to start with, and we ourselves didn't have any contacts that were working on this field of the human influence of trees. So I'm really grateful that Hien reached out to all of the researchers, and super grateful for Andrea for helping them with the experiment. So now we actually have a data set that we can start working on, that we can start post-processing and creating a visualization out of it. So it's kind of more like a common ground now for us and something we are used to. But even that, we are now working again on an AR installation, so of an AR visualization. Basically, the artists show us like a different perspective on how to do those. So there's a lot of creativity involved. For example, those large banners that show how large the data set actually is. I think that is super interesting because every time we have guests coming, we basically tell them the scientists have these huge data sets that they want to explore and that they want to communicate to others. And to actually have it visualized like that, I think it's a super interesting idea. And I also really like what Daniel said, that the goal of their installation is for the users not to instantly understand it, so that they're more interested. And I think that's very counterintuitive for us, because we usually focus on creating something that helps the scientists understand their own data set, and more importantly, helps other people who are not in the field understand it. So I think that's just a different perspective on the work we usually do, and we can learn a lot from the artists in that aspect.
Thank you, Suhan.
Okay, so
Yeah.
I just want to stress that what Andrea said is very important, that it's about the process, how they actually worked together. That's what we want to see. It's less about creating an art piece for an exhibition afterwards. And if you could remember that with your installation, to actually also show that process is important for us. Yeah. And I'm sorry, I have to leave for a different video conference. So bye-bye.
Thank you.
Bye-bye.
Okay, Hien and Daniel, would you want to close it off like with your experience of the collaboration, and then I'll do the outro?
Yes.
Can I start?
Yeah, Daniel, please.
Okay. Yeah, for me, it was super interesting, actually. First time really working with data scientists and engineers. I mean, not really first time, but like in a scientific way. Usually I worked with scientists more in an economical way in companies, and I think the freedom we had here and the possibilities, also like the technical possibilities, and that you were really opened to our approach, our artistic approach. I think that's super valuable, and I really appreciate the work together. And yeah, that from my side was really interesting.
Thank you, Daniel. So I can continue. So yeah, for me it's the same. So I'm super grateful that Andrea and Susanna has been supporting me so much on this. And yeah, so it's like it's a whole process, and I'm just feeling that like your openness, and that I can come to you with any kind of question. That's really awesome, and that's really help me a lot. And I think that this collaboration, this interdisciplinary approaches does give me many more possibility to form a new kind of sound, or new kind of forms, or visuals. So I'm super excited and really think that it's still a challenge, I guess, to combining science and art together. But I think it's the process that's the whole point, and I also plan to further continue with the collaboration with scientists and also different approach in different fields. Yes.
Okay, great. Thank you. Thank you all for listening. I thank everybody involved in the discussion in the end and the presenters, of course. If you are interested in what we are doing, check out the starts.eu website. We have our own sub-website /AIR, but on the starts.eu website, you can find all kinds of different residency programs and art science collaborations. Check out all of the parties involved. Hien, of course, the University of Florence, and everybody from our Starts AIR consortium, who I'd like to thank in the end. Thank you also to the European Commission for funding this. So if you like what you see, like the video, subscribe, follow Starts on social media, and subscribe to the Starts newsletter. There's always something interesting going on there. So thank you for listening, and goodbye.